Now we're going to look at two sample tests. So far we've looked at one sample test with averages and proportions, and averages we had both large and small. We're going to do the same here. We're going to have three different kinds of two sample tests: average, large, and small. That's the first two tests, and then the proportions test. We will start with a simple case. We will start with average, large, with all two sample tests. Essentially what we have is two groups, group 1 and group 2. These two groups could be either subgroups of an entire population, or they could just be thought of as two distinct groups. So for group 1, there's a true average out there which we'll call mu1. Right? We'll have subscripts on everything. And there's a true average for group 2 out there which we'll call mu2. Now while we really don't care what the values of these averages are, what we care about is whether one is equal, not equal, greater than, less than the other. Alright, so we care about the difference between the two. To figure out what's happening between those two averages, we need samples for each group, so we'll have a sample size n1, sample average x bar 1, and sample standard deviation s1. And similarly for group 2, we'll have sample size n2, an average there x bar 2, and standard deviation s2. We now have twice as much data as we had before, so our formulas get a little larger. Alright, so this is an averages problem, so we have to be concerned with degrees of freedom. For a two sample averages problem, the degrees of freedom is n1 plus n2 minus 2. Essentially we're adding n1 minus 1 degrees of freedom for the first sample plus degrees of freedom from the second sample together, so we have n1 plus n2 minus 2. And as always with what essentially are t-tests, if the degrees of freedom is greater than or equal to 30, we're going to use the z as an approximation and do the large sample test. And that's the first type of test we'll do here. Alright, so a lot of what we're going to do in these two sample tests we've already done in terms of setting up hypotheses, one or two tail, interpretations, decision rules, that sort of thing. The types of hypotheses we have in two sample tests go as follows. For two sample, two tail, have mu1 is equal to mu2. You can think of that as they're the same. Or another way of thinking of that is that mu1 minus mu2 is equal to 0. For the alternate of your two-tailed test, mu1 is not equal to mu2. They're different. Two averages in the two samples are different, and you can think of that as mu1 minus mu2 is not equal to 0. Let's just look at one tail example. Let's do a lower tail, and that would be mu1 greater than or equal to mu2. One is bigger than the other, and the corresponding alternate would be mu1 less than mu2. Again, remember or note that you can think of these as also being mu1 minus mu2 is greater than or equal to 0, and mu1 minus mu2 is less than 0. And of course we have another one-tail test example, but you can see that all the right-hand side values of these population differences are equal to 0. That's important when we get to our z-calc. Before we go there, let's talk about one-tailed tests and asking the question, which tail for a one-tailed test? And to figure that out, we find out whether x bar 1 is greater than or less than x bar 2. If it's greater than, alright, then it's an upper tail test. Where the alternate would be mu1 greater than mu2. And that should be no surprise given what we've done so far for one sample test. And similarly, if it's less than, then it's a lower tail test. And of course, again, not surprisingly, the alternate would have that less than sign in it again. So mu1 less than mu2. Alright, now let's look at the formulas that we use. It's a large sample test involving calculating a z-value, so z-calc is the sample difference, so it's x bar 1 minus x bar 2, that's the sample difference, minus the hypothesized population difference, mu1 minus mu2, divided by the standard deviation of the sample difference, so it's s sub x bar 1 minus x bar 2. Note that, as I said above, all these right-hand sides here, after we put the difference on the left-hand side, all those right-hand sides are 0. Okay, so mu1 minus mu2, for all the problems we do, all of them will be 0. Alright, and next the standard deviation, s sub x bar 1 minus x bar 2. Alright, this is actually an approximation we use for large samples. It's s1 squared on n1 plus s2 squared on n2. Alright, and that's all we need to do our tests, apart from all the other stuff we've done so far.